Hey class, welcome back. Today we're going to have a very brief look at scheduling, documenting, and permitting. And we're going to keep it brief so that you have ample time to work on the associated homework. With these topics, scheduling and permitting especially, it's more beneficial for you to get some practice. So we'll prioritize that in the next couple of weeks. But it's still going to be useful for me to give you an overview. So let's get into it. So schedules. Schedules are not just timelines. In project management, you really need to pull out the major milestones and the minor milestones. So these could be goals and sub-goals, and you need to attach those to deadlines. You also need to pull out deliverables, and again, you hear me use that in reference to anything that you're responsible for producing. This is your project management homework, basically. This could be a report, a map, a plan, anything that you are either responsible for producing yourself or you're responsible for getting out of a contractor or another staff member. Ultimately, you want to use the schedule you create to make sure that those deliverables are delivered on time. And then finally, activities. Here you want to take a hard look at duration and completion dates. And why this is so important is so that you can monitor the quality and expediency of each deliverable and action, but also so you can make adjustments, because invariably you're going to need to make adjustments for various delays. Let's have a look at an example. This comes from your book, your textbook, and it's a pretty good example. There are lots of ways to represent project schedules, but most of the time what you see is the Gantt chart format. Maybe you've encountered Gantt charts before when you have been working or studying. Pretty much every industry uses them. So it's a very good skill to develop. You'll be well served to know how to do this. But even though the Gantt chart itself can look different depending on which spreadsheet you're using or which software you're using, fundamentally what you have are the activities, the start and end dates, and the duration of each activity. So let's have a look here. So in this particular project, you have demo plans, meaning demolition. Something on site needs to be taken away before the project can commence. That flows right into planting plans, which flows into producing construction plans, simultaneously producing irrigation plans. And then out of all that, you're expected as a project manager to produce a bill of materials. Basically, that's your receipt of things that need to be purchased for the project to proceed. Okay, so let's take a closer look. Demo plans, we have a start date, January 1st. We have an end date, January 8th. So in the middle, we have a duration of 7 days. Pretty straightforward. That flows right into planting, starting the very next day, January 9th. This is going to take a little bit longer and probably take more resources. It's going to take a full 2 weeks or 14 days. And then we have a longer period yet in which probably a contractor is going to produce construction plans and irrigation plans. So you get how this works. This is a more involved example. So this is the work breakdown structure, or WBS. So you have the activities listed here. You have the duration in days, and of course this could be months or years depending on the scope and scale of the project. You have the person responsible. So let's say you're working on a team that encompasses lots of people. Well, you better make sure that you assign different people to the different tasks, and don't lose track of who's doing what. And And then you have these bars that indicate the beginning and ending of each activity. And that's a really easy way to be able to visualize the flow, the workflow of the entire project. So you have the specific duration listed here, and then you have a visualized duration here with these bars. And here, of course, we have a time step that's maybe a little different. We have a monthly time step versus days. Everything just needs to be, all the units just need to be correctly identified in your Gantt chart. All right, you can also create another column to identify costs and resources associated with each activity. That's not a bad idea as well. That's just going to help you produce your invoices later and make modifications to your budgets as you go. Budgets being something that we're going to talk about next week. Okay, so that was a very brief look at Gantt charts and the WBS timeline. Like I said, you'll get some practice with that and you'll feel more comfortable there. What I want to do now is have a look at some typical plans. So I mentioned earlier in this example that construction plans are something that needs to be produced for the project to move forward. Sometimes you hear these referred to as construction specs, and there is a little bit of a difference. So plans tend to be fairly generic, and they help communicate to a grant funder or to an agency what's going on. Specs have some very, very specific information on them that you hand to the contractor who is digging and dozing. And that contractor will be able to read and interpret those specs because of their training and actually build it on the ground. Now, that doesn't mean you're not going to monitor the contractor very carefully. You will. We will talk about that more later when we get into project implementation and oversight. But for now, just be able to distinguish between a plan and a specification. Specification just has super specific information for the actual construction, whereas plans are a little bit more generic and are used in the project planning phase. That should be pretty self-evident. Let's look at some examples. So this is a plot and utility plan from your book. And basically what this does is it outlines the boundaries of the site and identifies legal constraints, legal access requirements, etc. So for example, here we have a right-of-way, meaning someone has access through this portion of the property. Maybe it's a utility, maybe it's a county road, etc. This is a road that needs to stay open, so it can't be obliterated, it needs to stay there. Fences, environmentally sensitive areas, basically, oh, here's a water line. This does not contain much information. It's just the most important aspects with relation to infrastructure. So roads, power poles, pipelines for water or gas, property boundaries, things that need to be respected within the scope of all the other plans. Now, here is something that has a lot more room for interpretation. This is a removal plan, meaning a lot of times you're going to be moving earth around, you're going to be moving dirt around, and some of it may just be pushed around on site for the sculpting of the landscape, and some of it may actually be removed. So maybe you have fill that is contaminated and needs to be removed to a landfill, that kind of thing. So a removal plan is going to highlight some of the individual trees, for example, things that you don't want to disturb or environmentally sensitive areas, but it's also going to pull out and articulate the areas that will be changed. This is perhaps not the greatest example But a engineer or a contractor should be able to look at a removal plan and say, okay, we're leaving that area alone. Over here, we're going to be excavating down to such and such elevation. A grading plan gets even more specific because you see here that it's really a topographic map and it's really tied into specific elevations. So this is a restoration project grading plan in which biochannels were used to concentrate water following floods. And you can see some of those channels outlined here. You can see some higher areas. You can see a grade going up a slope. Basically, this is a topographic map that includes the restoration activities. Okay, one thing that's super important with any kind of ecosystem restoration is that you establish a baseline. What I mean by that is you have a professional surveyor come out and survey the site and install a transect in which the elevations and the locations of the property boundaries are all identified and flagged on the ground. What that does is it helps the contractor and whoever else you have on site doing construction later reference that baseline. Because imagine that a site is going to look very, very different over time. Imagine that you're, for example, removing all the vegetation and starting over. It's very easy to lose track of where those property boundaries are. It's very easy to lose track of elevations with respect to where you started the project. So that's why having this surveyor put in a baseline system of markers is really helpful. Okay, planting and irrigation plans. This should be pretty straightforward. Basically, it's an opportunity to communicate what plants you want planted, how big they are, how many you want planted, etc. And usually there's a little color coding or hatch marks to indicate a certain zone that's going to receive a certain community of plants. Sometimes you'll say, okay, these are going to be 1 gallon pots. Sometimes you'll say these are going to be willow cuttings, etc. But basically you have polygons on a map indicating to the planting team what to plant and where. Okay, I mentioned earlier the bill of materials. You know, this is a tool that project managers need to get comfortable with, in which they list all the activities, but more specifically, they list all the purchased items or charged items associated with each of those activities. So for example, as part of the restoration, we need a whole bunch of mulch. Here's the unit of measure in cubic yards. And the estimated quantity we need is about 8,000 cubic yards. So what you do as a project manager is you look at the project requirements, you look at the project activities, and then you brainstorm all the things that will be needed to complete each of those activities. So here we have a list of different types of plant groups. We have native seeding. We have the actual work of establishing the plantings. That's probably someone who is going to be weeding and irrigating, and the charge that it takes, the charge that they're going to require to do that work. We have some electrical material here, roadside clearing. So it's not just things that are purchased at your Home Depot or your local hardware store. It's also services provided to the restoration team by a contractor. And you do your best to then attach a preliminary price to that, to each of those activities. And then you total it up. So the bill of materials identifies all the material components of the project, and then it attaches prices to each of those. It's a budgeting tool, but it's also a communication tool, and that's probably the takeaway here, is that it's a document that's going to change over time, because you may get halfway into a project and realize that you need twice as much of something and you have surplus of another thing, and you'll need to make adjustments. As with all projects, it's essential that these things go out for competitive bids, and this is a requirement, a legal requirement, if you're working for some sort of public agency. And that's something that we'll touch on more later. All right, I mentioned the difference between plans and specs. Well, here's an example of a construction spec. This is a barrier, so this is perhaps a parking barrier or a roadblock. You know, it's one of the things that helps you control public access to your site. And you would think that that would be super simple, that you could just tell the contractor what to build. But in fact, you need to provide one of these plans with very specific dimensions. And that's really important, just to make sure that you get a lasting and quality product versus something that's thrown together and maybe won't accomplish your goals in the long term. So these specs are performance and outcome based. Another reason that these are important to produce is so that if your contractor who does the work does something that doesn't meet your expectations, you can pull out these specs later and hold them to that standard and make them go back and fix it. When you put this specification in their hands, you're putting the liability on them to meet those standards. And so that's why this is a really essential part of the early project implementation process, is building easy to understand plans and specs that are basically communications tools. Okay, one last thing here, as-built drawings. You'll hear me refer to this a few times, as-builts. As-builts are basically the restoration plans once the project's over. So you may have a project that maybe didn't change much from beginning to end. Maybe it pretty well matches your initial conceptual plans. But even the smallest change to the project, and believe me, changes do happen on the ground, on the fly. And that's something you negotiate as a project manager as you go. Your engineer, your construction firm may approach you and say, hey, look, we didn't count on this. And we need to maybe alter the design just a tad, go around this, dig a little deeper, use different types of materials, etc., etc. Well, even the smallest change needs to be documented in your journal. You need to be taking pictures. And then ultimately, at the end of the project, you're going to have your team produce these as-built drawings. And basically, that's just your way of saying, this is the finished product on the ground. This is actually what we completed on the ground. And that's really important because it also protects you from undue liability. And it informs your effectiveness monitoring as well. So let me elaborate on both of those points. If a funder comes to you and they only have the initial conceptual drawing, and they've visited the site and they realize, wait a minute, this isn't what we thought we were funding. This is not what we thought we paid for. That's going to be tricky. You're much better off if you provide as-built drawings to everyone involved, the permitting agencies, the funders, etc., so that they all know what was, in the end, completed on the ground, and there's no miscommunication there. Now, as far as as-built drawings informing effectiveness monitoring, you know, if you have a team of ecologists and biologists who are monitoring a site over the next several years to determine how well it performs, as an ecosystem, they need to know exactly what took place out there. They need to design their before and after monitoring to reflect the actual situation on the ground. So those are a couple of ways in which as-built drawings are quite important. All right, I think that is it. That was just a brief look at scheduling, documenting, and permitting. The homework will go into much more detail, but I hope that was helpful, and I look forward to seeing some of your work in the near future. Thank you so much.